Individuals with large fat cells tend to lose weight over time, while those with small fat cells gain weight, a Swedish study finds. New research being presented at the European Congress on Obesity, ECO, in Venice, Italy, May 12-15, suggests that it is possible to predict if someone is going to gain weight based on the size of their fat cells.
You fat, reckless fat pig!
Baby, ooh, did you lose weight?
Individuals with large fat cells tend to lose weight over time, while those with small fat cells gain weight, the Swedish study found. The size and number of fat cells are known to determine fat mass, how much body fat someone has. However, their impact on long-term changes in body weight is unknown. An average of 15 years, range 5 to 28 years later, the participants were seen again and body weight, BW, BMI, and total body fat, BF, were measured. Individuals undergoing bariatric surgery or receiving anti-obesity drugs, Enta-69, were excluded from the analysis. Initial fat cell volume and fat cell number were significantly related to changes in all three measures over time, BW, BMI, and BF. Having a high number of fat cells that were large was associated with decreases in the three measures, while having few but small fat cells correlated with increases in weight, BMI, and body fat. This was the case whether or not individuals were living with obesity. The effects of FCV and FCN were additive, and together explained 32 to 35% of the variations in changes over time in BW, BMI, BF. The associations between FCV and changes in BW, BMI, and BF were still significant when initial age, physical activity, length of follow-up, and sex were taken into account. In other words, large cells were linked to future weight loss, and small cells to future weight gain. Professor Arner says, "We can only speculate as to why the size of a person's fat cells seems to predict their future weight. Body weight decreases when energy expenditure exceeds intake, and the body burns off fat to compensate. Our results suggest that the loss of large fat cells makes more of an impact on weight than the loss of small ones. It is a bit like having a room filled to the top by a few large balloons or many small ones. It is easier to make empty space in the room by letting out air from the big rather than the small balloons." As to why having small cells might make it easier to gain weight, Professor Arner says, "Conversely, it is easier to fill up the room if many small balloons increase their volume a bit, as compared with having few large balloons and filling them up just a bit." The researchers conclude that FCV has a strong influence on long-term changes in body weight. Thus, measuring FCV early in life could be important for weight management later in life. Professor Arner adds, "It could be of great clinical value to have information about fat cell size before starting a weight management program. If it is the case that those with large fat cells find it easier to lose weight, those with smaller cells could be given extra support." Unfortunately, there isn't an easy way of measuring fat cell size at present, but it is something we are working on, and we're close to coming up with a solution. There are advantages, however, to having small fat cells. Professor Arner says, "It is well known that people with small fat cells have a better metabolic profile than people who are the same weight but have large fat cells. This means that if someone with small fat cells does gain weight, it may not raise their risk of conditions such as type 2 diabetes and high blood pressure as much as if they had large fat cells."
Trying to lose weight?
That's all for now, science explorers. We've uncovered exciting new research. Don't forget to subscribe to our channel for more scientific discoveries and space secrets. See you in the next video, and take care.